Now we're going to look at the core concept of solving real-life problems. So, we understand the problem, what is the unknown, what information is being given, what is being asked, and so on. Now, that's the top part of this slide is what's in your journal. The bottom part down here is something that another teacher and I created years ago, and we like to use it. It's rrr.tips.core, and it's just the acronym that we use to recall that read, think, and identify. And so we have to read the problem as many times as we need to think about it and identify what we need to know in order to understand the problem. Then we're going to make the plan. Then we're going to solve it. And then probably the most important part is to check over the reasonableness of the answer. And if we can do those things, then you're usually going to be pretty successful with any type of problem that you encounter. So here's the first problem. It says in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So we're going to use the formula distance equals rate times time. Well, the distance is given to us is 200 meters. The rate we don't know, but the time we know is 19.32 seconds. So if you look at this, it's a one-step equation where we're having to solve this by using the division property. Since the variable r is being multiplied by 19.32, we're going to divide both sides by 19.32. And if we do this, we're going to get our answer. When we divide this out, we'll get approximately 10.35, and that would be 10.35 meters per second. And so we always want to make sure we label it. So 10.35 meters per second. And we think, well, does that make sense? Well, if he's running 200 meters at 10.35 meters per second, it seems like it would take him about 20 seconds to do that. Core concept, common problem-solving strategies. So we have lots of different ways that we can try to solve a problem, and these are just some suggestions to help us in developing our plan in the rrr.tips.core. The plan is to use a verbal model, draw a diagram, guess and check, make an equation, whatever we need to do in order to solve that particular problem. So here we have on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to a negative 4 degrees at 9:27 a.m. How many degrees did the temperature fall? Well, it really would help if we kind of thought about it on a thermometer. So if we have a thermometer here, and we put 0 here, and we go 54 degrees here, well, a negative would be down here, negative 4 degrees. And so if we want to know how far it dropped from here to here, well, we have to go 54 degrees just to get to 0, and then another 4 degrees to get to a negative 4. So I would say that the temperature fell a total of 58 degrees. Now, if you notice, I didn't use an equation at all. I just used a diagram to show this. Now, we could use an equation if that's what we wanted to do, but we don't need to. But if we did, we'd have 54 degrees where we started. It dropped a temperature to a negative 4 degrees. And then we go ahead and solve this. Well, here we want to solve for t, so we're going to get rid of the 54 first by subtracting 54, because again, the 54 is positive, so we want to subtract it. We'd have a negative t is equal to a negative 58. And now we divide by the negative 1, and we get t to be 58 degrees. And if you notice, the equation is probably even more confusing than just drawing the diagram. And again, we're just wanting you to solve the problem. So any of those methods that we come up with can be used to help solve a problem. So what I want you to think about and be able to do is describe in your words how to solve a one-step equation. So think about different types of one-step equations, either using addition, subtraction, multiplication, or division, and describe in your words how you would solve a one-step equation. And if you want, go ahead and do this last problem as something in your notes to decide if you feel confident of how to solve a one-step equation. All right, thank you very much, Titans. Make sure you bring your student journals to class tomorrow, and we'll talk about those tomorrow. Good evening.